Okay, so welcome back once again, guys. Now, in this lecture, I'll be talking about a new project with respect to our deep learning. So, where we are going to build a neural network, and we will try to solve a regression problem, by the way. So, where we will try to see that how my deep learning model will be able to learn and it will be able to do a prediction. And if you have already done a previous project, then obviously it is going to give you an advantage. Not just that, so we are going to even productionize this particular project, and we are going to test an API end to end, right? End to end, we are going to test it. We are going to productionize it on a render after converting my project as a Docker. And then I'm going to even show you that how you will be able to test this API with the help of Postman. I have already done that in a previous project, but again, I'm going to show you the exact same step with respect to this particular project. So first of all, guys, let me share my screen, and let's go ahead and open up a VS Code, Visual Studio Code. And let's move ahead inside this project in a step-by-step manner. So here, what we are going to do. So basically, we are going to build a energy consumption project. So first of all, open up a new folder, a fresh folder, and then try to create a new folder. I'm going to give a name to this folder as a energy underscore consumption. So this is the project which I will be building. I will be doing in a step-by-step manner. Okay. So for any project that we are going to build, the very first step that we have to take is place a requirement.txt file. I believe we all are aware about it, right? Because this is something that we are doing again and again and again. So requirement.txt file I'm going to place. Now, once requirement.txt file is available over here, now let me build an environment. So how I will be able to build the environment? Simple, right? So here I can try to do a conda create -n, and I can try to give an environment name energy cum, energy consumption. Yeah, energy eng I can try to give, and then Python is equals to 3.10, as you are going to use a TensorFlow. So obviously Python 3.10 is the stable one. Otherwise, it is not going to work. You can use a lower version as well. That's completely fine. So energy consumption, and let's see. So we'll try to build the project one by one. Okay, so this environment is created. Now just try to do conda activate. Fine, conda activate. Now CLS, clean the screen, and in this directory I have a requirement.txt file. So just try to do pip install, which is a standard approach, right? So pip install -r requirements.txt, and whatever I have mentioned inside my requirement.txt, it is going to install each and everything. Sorry, I think it has not activated my environment. Oh, I think I have not activated my environment, guys. So let me check. Command prompt conda activate eng underscore cum, and now I can do pip install -r requirements.txt. So now it's installing. Yeah, as you can see, because previously it has just given me like a requirement all satisfied within a fraction of a second. So I had a doubt that maybe it has not like installed all these new things that I have mentioned inside my requirement.txt file. Okay. Now, meanwhile, what we can do is that we can try to look into a data set, that how my data set actually looks like. And I'm going to place my data by creating a data folder. So let me create a data folder over here, and inside this data folder, so I'm going to keep my energy file. So this is the data file which I have created. My environment is ready, up and running, right? My environment is ready. So I'm going to close this part, and now let's try to talk about the data. Let me open up this data into a Excel sheet, so that it will be more visible to all of us. Now, if you will look into this data, so we have a temperature, we have a humidity, we have a wind speed, we have hours of a day, we have a day of a week, and we have a energy consumption. So this is the small data set that we have prepared. The whole idea behind this data is to teach you that how to train a deep learning model for a regression. Means basically we have to predict energy consumption. At the end of the day, this is something that we have to technically do. Fine. So now let's talk about data set a little bit. So what this data set is all about, and what it is talking about. So temperature, it's available in a degree centigrade, by the way. So temperature is a current temperature, you can say. Humidity is a current humidity percentage it is trying to showcase. Then wind is basically a mile per second, you can say. Wind speed is given to me. Hour of a date will vary in between 0 to 23, 0 hour till 23rd hour. Days of a week, so it simply means wherever 0 is mentioned, like 0 is mentioned, it simply means that I'm talking about a Monday. Wherever 1 is mentioned, I'm talking about a Tuesday. Wherever 2 is mentioned, I'm talking about a Wednesday. So this is how a day of a week is been labeled. And then energy consumption. So energy consumption is basically available into a kilowatt, right? In a kilowatt, this is available to me. So now what we have to do, so we have to consider these columns as a X column, right? And we have to consider this as a Y column, and we have to build a regression model. So where if I'm going to give these as an input, temperature, humidity, wind speed, hour of day and day of week, if I'm going to give that as an input, it should be able to predict energy consumption. It should be able to predict energy consumption for me, a very simple use case. Like I said, so data is not my focal point over here. My focal point is to show you that how I will be able to build a model, how I will be able to deploy it, and then how I will be able to test it. So that's my like a whole target over here. So fine, this is my data set. I'm keeping my data inside my data directory. Now let's close it. Yeah, let's try to close this particular data wala part. Now, so requirement.txt is done. This one is done. Now what I'm going to do is that I'm going to create a file called as train model.py file. So train underscore model.py file. So which is going to give me a model, right? Which is going to give me a model, and this model I'm going to use it to deploy somewhere, right? This is something which I'm going to use to deploy somewhere at some places. So to do that, let's do it quickly, guys. So here, right? So here, first of all, we are trying to do an import. So we are trying to import a pandas, numpy, scikit-learn, TensorFlow, and all those things. Parallelly, let's do one thing. So let's try to open up a test.ipynb for explanation purpose, by the way. Yeah. And try to select the same kernel. So energy consumption kernel, so that our environment is going to be intact and it is going to be same. So now let's try to import all of these things, and there is no issue except Jupyter notebook. So it is going to install a Jupyter notebook. Just wait for a couple of minutes, guys. It will be done. This is a regular process that we do all the time. Okay, so it's done. Now let's try to import. So import is successful. There is no issue at all. Now what we are going to do, so we have to load a data. We have to read a data. So simple, we are going to use this syntax. So this is my data directory, and I'm trying to call os.part exist if data part exists. So data is available inside this folder. Just try to like assign this particular variable and check it basically. And then if all is well, then try to call pandas.readcsv and try to pass a data path. You can remove this piece of the code. That's completely fine. This is just for the validation purposes. Now, once this part is done, so I have to create my X and I have to create my Y. My X is going to be these column and my Y is going to be energy consumption column. So let's try to create my X and Y. So here, what I'm trying to do, so I'm trying to use this one for my X and I'm trying to use this one for my Y. So I'm saying that okay, so try to select all the rows and just try to select all the column except minus one. Minus one means except the last one. So this is going to be my X and this is going to be my Y. If you would like to test it, you can try to test that as well. So here I can try to test it, and maybe I can try to check that what is my X, by the way. So my X is all this first 1, 2, 3, 4, 5. So this 5 column till a day of a week, as you can see, like till a day of the week. And then if I'm going to test my Y, so my Y is going to be the last one. So my Y is going to be the last one. Fine. So X and Y segregation, I'm able to do it. Now, once my X and Y segregation is done, then we can try to divide our data set. We can try to divide our data set into train and test. And as we can see that my data set scale range is varying a lot for all of these columns, right? All of these columns: temperature, humidity, wind speed, hour of day, day of the week. So maybe I'll end up creating a bad model, overfitted model, underfitted model. So keeping that in a mind, we will try to standardize our data set. So we are going to call a standard scaler as well. So first, let's try to split our data, and then so X train test split I'm trying to call. Standard approach, once again, we have done that hundreds of times in a past. And then we are trying to call a standard scaler. We have done this as well, again, more than 100 times, right, in a past. So we are trying to standardize this particular data set. Now, once this standardization is done, we are going to basically build a model. We are saying that okay, so in a very first layer, I'm going to have a 64 neurons. In a second one, 64 once again. I can try to add more and more layer over here. And then in a last layer, I will be having only one neuron. And I'm not keeping any kind of an activation function because I'm not looking for a probability, right? I'm looking for basically a final outcome. I'm looking for a regression. So this is a difference you will be able to find out between a classification model and a regression model. I'm looking for some value. So whatever value that I will get from the previous layer, combine it, give it to me in a last layer. So 64 neuron, I'm trying to pass my data over here, and then this is the model. If I would like to check that what is my model size, so maybe let me define all the above part over here. So yeah. So here, if I'm going to call model.summary, so it is going to show me the architecture that, okay, so this is the number of parameter which I'm going to train, and this is the first layer, second layer, and this is going to be the final output layer. So this is a very simple model which I have created, right? And this is something which I'm going to train upon. Yeah. So I'm going to train this particular model. Now, to compile this entire model, so what we can do, so we can try to like a call model.compile. We can try to pass a optimizer loss wise. So mean squared error, we are going to pass, as we are talking about a regression problem. We are not talking about a classification problem. So my loss function is going to be changed and optimizer is going to be same. Yeah. Standard approach once again. Now, so once it's done, so we are going to call a model.fit, which is eventually call my training. So I'm going to pass my X train and Y train. 50 times I'm going to pass the whole data. So I'm going to update the weights after every 32th data, right? This is the meaning of a batch size and validation split. So 90:10, in which I'm going to divide the data for the validation during a training. Now, once it's done, right? Once it's done, so we can try to evaluate this model. So model.evaluate, we can try to pass X test and Y test, and it is going to evaluate it, and it's going to give me loss, and it is going to give me mean absolute error. Simple, right? And then once this part is done, I can try to call a model.save, as you can see. So model.save. So I'm going to save this model into a H5 format. Plus I am trying to do a standard scaler. So I have to save this particular instance as well, so that at the time of testing, I will be able to call it. So I'm going to basically save this one. Now, if everything is going to work fine for me, and again, guys, so I'm not like, calling this one, or I'm not going to explain line by line. I'm not writing a code line by line. The reason is very simple, that we have done all of these things 100 times, right? 100 times. So now we are in a position where we can understand all of these things in one single go. Now let's do it. So let's try to call the training part of this model. So CLS and Python, Python, Python train model.py file. And let's see. So if we are going to get some issue, hopefully will not. Okay. So we are able to train the model, it looks like, and we are able to save the model. So H5 file, I'm able to save it. And then this scalar.save, or maybe I can try to use maybe a job lib over here, which I'm already using, right? And I can try to save it as a pickle file, .pkl file. So in a pickle format, I can try to save it, or even in this format, I can try to save it. Now, once this model has been saved, right? So I just need these two files, one and this two, right? I just need these two files. I can try to pass the data. Which data? So I can try to pass a data for this one, and I will be able to test it, right? I will be able to test it. So I can do a model testing. I can do a model testing over here. So now to do a model testing, I would like to call these two things, these two models, scalar model and energy consumption model, with the help of FastAPI. Yeah, with the help of FastAPI. So I would like to basically, do a testing. So to do a testing, maybe I can try to create a new file called as app.py file. And we all know that what is the meaning of API, right? Kind of a route where we will be having some function sitting over there. So with the help of route, so we can try to call it from anywhere. And that is something called as API, right? That is something called as API for me. So here, right here inside app.py file, so try to call all the standard library. So FastAPI, I'm trying to call, and then try to create an object of a FastAPI. Simple, right? Object of the FastAPI, and then try to load a model. So which model? Energy model.h5. This is the model, and scalar model. Try to load these two models so that first of all data will go here, and then it will try to go over here to do a prediction. And then just try to make it compatible with the pydantic. Yeah, pydantic. So we are going to pass a data as a list. It is going to check a type check, by the way. So this is basically a pydantic I'm trying to call. And then there is a predict function which I have written. So predict means, so it is going to take whatever data that you are going to pass. So it is going to take it. It is going to convert that into a compatible format. Then scalar.transform, it is going to call a scalar, the model which I have already saved. So it is going to basically like transform it, and then it is going to pass this scaled data into a prediction. I will be able to get a final return. Very simple, right? Now, if I have to convert that in an API, so I have to simply write @app dot post, and then here, so I can write /predict, only this much, right? Only this much I have to write, and automatically, right? Automatically this entire things will be exposed as an API. Once I'm going to run it in my local, so it will be exposed on my local host. And once I'm going to like host it on a cloud, it will be available on a cloud. So here, what we can do, we can try to test it first of all, that whether it is working for me or not. Now to test it, I can write over here that UVCon for a FastAPI like a execution. I have an app file, so consider that as a app, and then basically try to call reload. Now if everything is going to work fine for me, so I will be having my API. Otherwise it is going to give me some issue. Full object, keras, matrices, class name, function. Okay, so it is telling me that could not locate a function. MSE make sure a custom class R. Fine. So model dot predict. Okay, so let me fix this issue, by the way, or I can try to even go to this particular URL and I can just try to do a little bit of check over here. So this URL /docs docs, and yeah, so site can't be reached. So basically my API is crashing. Let me fix the issue. Okay, so just a small fix as per this error. So inside my training, so I have used loss is equals to MSC. It is not able to recognize it. So let's try to change it as a mean squad error in this way, so that it will be able to recognize it. And then just go over here and delete these two files. Yeah, so I've just deleted it. And then once again, so let's try to do a training. So here Python train model.py file. Within a fraction of a second it is going to train, and I will be having my new model, new version. So I've just done this change, guys. It was not able to recognize it. It was giving me an error for that. So CLS, and then I can try to run UVCon app, my backend app, right? I don't have to do any kind of a changes in that one. And let's see. Yeah. So now I believe I'm going to get a good news. Application startup complete, and now just wait for a couple of more seconds. So I will be able to see something at this particular URL. Okay. So now if I'm going to click on this URL, I'm able to see a predict function, right? I'm able to see the predict function. And here, so I can try to pass my data and I will be able to get my final output. So here I can try to pass my data as a list. So whatever like a data which I would like to pass, I can try to pass it. And I can just try to call try this out, and maybe I can try out passing some of the data as a list over here. So let me do it. So let me try to like pass this data as a list. So here maybe I can try to use one of the data, paste it here, comma, comma, remove all of these white spaces which we have in between. So comma, 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 and then comma. So this is the correct format that we have now. Yeah, this is the correct format that we have now. Now I can try to click on execute and let's see. So whether I'm okay. So prediction wise, I'm able to get this as a energy consumption. So 27.940. As per my data, it was supposed to be 38.7, but yeah, we are able to build a model, a bad one. Obviously, maybe we can try to increase a number of layers over here. We can try to change maybe a epoch. We can try to change maybe a batch size. There are a lot of scope that we have, and based on that, I will be able to do a lot of fine tuning. But yeah, so we are able to build a model and we are able to see the prediction with the help of this fast API. So once I'm able to see the prediction, so maybe I can try to test this same API with a Postman. And in my previous lecture, I have already talked about a Postman. That Postman is a tool by which you will be able to test. You will be able to test the API. So let me open up a Postman, and I have already talked about that, how to do installation of the Postman in the previous lecture. So here I'm going to open up a new tab. I'm going to select a post as it's a post one. And then I'm going to pass this URL. So this local URL over here slash predict, fine, slash predict. Now header, so maybe I can try to leave it as it is. Body, so I can try to use a raw and I can try to pass a same data which I'm trying to pass here. Same data which I'm trying to pass here inside a body. So let me pass this data and then click on send, and we are able to get a prediction once again. So even with the help of Postman, we are able to test this entire application. Very simple, right? So just try to pass this URL. At this URL, I have a function, as we all know that at this URL, I have this predict function. It's running on my local host, on my local system. And here, so yeah, 200 means it's a good output that we are able to see. We are able to get it. Now, once we are able to do a testing with respect to a Postman, now what is next? So next, maybe we can try to deploy only this API. Yeah, we can try to deploy that as a API. Where? On a render. So let's close everything. So let's close everything. Yeah, let's close this one, and this one. And let's try to talk about just a deployment. So here I can try to create a new folder, and maybe new folder is not required. So here itself I can try to create a new file, and I can try to write it as a Docker file, Dockerfile, Docker file. So here I'm going to prepare my Docker file. Now what this Docker file is going to do, so it is going to help me out in terms of doing a deployment, and same thing we have seen even in my previous class. So here inside this Docker, so I'm going to install 3.10 along with the Debian operating system. Inside this, I'm going to create a working directory called as app. All this local file, I'm going to copy it inside this one. And then first of all, I'm going to run requirement.txt, and then this is going to spin my machine, and my app will be up and running at this particular location, right? At this particular location, my app will be up and running. Okay, so that's cool. Before that, so let me go to my app.py file, and here, so I'm trying to load a model, so which looks fine to me. Just a minute. So as such, I don't have to do any kind of a changes over here. So everything looks fine inside my app.py file. And technically, I just need app.py file. Other files are not required, but even if you are keeping it, it is not going to harm you. Yeah, it is not going to harm you. So let me run this Docker. First of all, let me test this Docker. And then after testing this, or maybe even without like testing this Docker, so I will be able to push this entire thing inside my GitHub repository, because in my previous example, I have already tested a Docker. So if you have missed that, so please try to go ahead with the previous lecture in which I was already talking about a Docker. There is a separate lecture you will be able to find out just with respect to a Docker. So maybe without testing it inside my local, because I'm like 100% sure that it is going to work. So let's try to push this entire code base inside a GitHub repository. So what I will do, I'll try to open up my GitHub, and here, so I'm going to create a new repository inside a GitHub. So new, and then energy is a repository which I'm going to create. Now inside this repository, I'm going to push my entire code base. So first of all, git init, git add. So here, CLS, clean the screen. And I'm going to do git init. And then I'm going to do git add everything. That's the reason. So we have a dot. And then git commit -m message. This is my energy project. So fine, commit is done. Now what we have to do, so we have to call a branch main. So branch main, call it, attach a branch. Already steps are given and we have already done that hundreds of times. And then finally push it to origin main. So push it to origin main. So once I'm going to push this entire code base, now if I'll go and refresh this GitHub repository, I will be able to find out all of these files. Yeah, all of these files I'm able to find out. Now what we are supposed to do, guys. So now we can try to open up a render. So you go to Google, render, and just go to this render.com, go inside the dashboard. If you have not logged in, so please try to log in. Otherwise, if you have already done the project from the past, which I have already taught you, so maybe you must be aware about the render. If not, just try to sign up inside the render platform. It's a platform, so which is going to give you an instance where you can try to deploy it, but a shared one with the limited resources. And again, so you don't have to add a card if you are not looking for a dedicated environment. So here, just try to click on new, just try to click on web service. And then from here, so you can try to select your GitHub repository in which you have a code. So energy is a repository. I'm going to like a select, and then language is equal to Docker because I have a Docker image. And then I don't have to do anything. I can select a free over here and then simple deploy web service. This is the only step which is required for this particular project. And if everything is going to work well for us, it will take at least 4 to 5 minutes of time, and you will be able to see your FastAPI up and running at this location /predict. You will be able to do the exact same thing that you are doing it with respect to a local URL. Simple, right? So just wait for 5 minutes of time and then we will be able to see the final deployed version. Okay, so looks like my API is live, by the way, and I can go and check over here at this URL. So /docs, my FastAPI seems to be live on this live URL. Yeah, I can try to do even a prediction. So just to do a prediction, I can click on try this out and I can try to pass the same data which I was trying to pass and execute. Let's see what is the outcome I'm going to receive. So prediction is 27.940. So yeah, this is the live API. Now I can try to integrate this API with any of the front-end application or any other application basically, right? So my API is live. I can try to do even a testing with this API. So maybe I can go to a Postman instead of using this URL, which is a localhost URL. I have changed it to my deployed URL. And then if I'm going to send, it is able to do a prediction, right? So my FastAPI is live, it's working, it's up and running, it's deployed. My backend is technically deployed. And yeah, so I can try to share this API with anyone. I can say that, okay, just try to do a post request and try to pass this data. Every one of them will be able to use my model. So pretty much amazing for all of us, guys. We are able to build another project. Let me summarize this part, by the way. So let me open up my Scribble ink. So what is the step that we have done, right? What is the step that we have done? So first of all, obviously, step number one, train the model, right? So after training a model, basically, we are going to expose it as API with the help of obviously FastAPI. And when we are trying to train the model, so basically we are talking about an artificial neural network based model. Obviously, this is the regression model that we have used. Now, step number 3 that we have taken over here, that test a model in local and with Postman. Fourth, Dockerize the solution. Fifth, deploy on render. Sixth, test once again. Simple, right? So this is the step that we have followed in this entire project throughout, and yeah, successfully we are able to complete this particular project. The whole idea, the whole intention behind showing you this project was very simple, to teach you that how in an end-to-end manner we can try to create our own API, we can try to train our own model, whether it's a small, it's a big, that's a different story, because with every model that story is going to change. With the data set, it is obviously going to change. How we can try to Dockerize this, obviously we are able to learn that part as well, and then eventually how we can try to deploy it on a render platform. So each and everything we are able to understand. So with that, thank you so much everyone, take care, and see you again in my upcoming chapters.